So this is a question. So a network is given. He asked us to find the Norton equivalent current across the terminal A and B. Okay. So already we know what is the Thevenin equivalent. Thevenin equivalent is the open circuited voltage. Okay. So now suppose if there is any network is given like this. Okay. Let us suppose it is a load. These are the two terminals A, B. It is a network. Okay. It is a network and it can be replaced by one current source in parallel with one resistance. Okay. And again we have to connect the load like this. So this is RL, this is called as the RN, it is called as the IN, right? RN and RTH are same. Okay. So here you have to write what? IN. IN is nothing but it is a short circuit current. It is a short circuit current. Current between A and B. Okay. It is a short circuit current between A and B. In the previously we have removed this load resistance RL. Okay. And we found the open circuited voltage. Here I have to short these terminals. Okay. I have to short these terminals. So I have to find the current. That is called as the Norton's current. So Norton's current is nothing but what? It is a short circuit current. Okay. Norton current is a short circuit current. So here to find the short circuit current, see, I have to short this. Right or not? I have to short circuit this. Then how can you get? Okay. See, observe this. Whenever you are finding this, see, this kind of question might be, see, whenever there is a resistance in the bottom line, you must care, right? See, observe this. So how can you find the short circuit current? So if you can find the short circuit current here, see, the equivalent circuit will be, I am writing the equivalent circuit. It is 16 ampere at an angle 0 degrees. Current source is there. Okay. Here there is one 25 ohm resistor is there and one more 15 ohm resistor is there. Here one capacitor is there and this is short circuited means, so this will also be short circuited. These two are in parallel, so I can remove this. Okay. So it will be merged into this. So here A and B. I have to find this current. This is called as the IN. It is equals to ISC. It is ISC is equals to IN. Alright. So I have to find this. So this is 15 ohm. It is given. Okay. 15 ohms is given. You have to be very careful while there is an element on the bottom line of the network. Right. So you can write this. See. This is one current. How much this current is 16 ampere at an angle 0 degrees is flowing in this direction, right? So the current is flowing in this way. Let us suppose this is I1 and this is I2. So this I2 is flowing in this direction, right or not? This I2 is flowing in this direction. But what is I2? I2 is equals to IN only. This is the current, right? So these are all in series. So this is I2 only. So I2 is equals to IN. Right? So from this IN is equals to total current. 16 at an angle 0 degrees. Total current into opposite resistance by total resistance. Opposite resistance is 25 divided by, what is the total resistance? Total resistance is, it is 40. 25 plus 15, it is 40. Plus, it is how much? It is J minus J50 ohm. Right? Minus J50 ohm. So minus J50 ohm. Right? So here you can simplify this. So here, so you can simplify it for the, okay, it is 60 at an 16 at angle 0. This will be is equals to 16 into 25 is 16 into 25. So 16 into 25 is, it is 100, it is 400. Okay, it is 400 divided by 40 minus J50, right? 40 minus J50 amperes, and you can further simplify this. Okay, so 40 minus J50, and you can take the magnitude. Okay, you can take the magnitude of this and you can take the angle. Okay, so this is the Norton's current. Norton's current is the short circuit current. Okay, and from this you can simplify as per the options. Okay, so this is the current. Suppose if you asked us to find the VTH for this question, what happens? If you ask us to find the Thevenin equivalent voltage VTH, then what we will do? The question is completed. Okay, now if you are asked to find the VTH, the Thevenin equivalent voltage across the terminals, what you can do? And Thevenin voltage equivalent and Thevenin equivalent resistance. How can you find? So this is the question. You have to find the Thevenin equivalent voltage. How can we find? In what approach you will use this? See, can we use nodal analysis? Can we use nodal analysis? If it is VTH, what about this? This is also VTH. If I use nodal analysis, there is a problem, because there is a, observe this, there is an element, there is a resistance under the bottom line of the network. So whenever there is a element between two nodes of any network in the bottom line, so you have to be very careful. Suppose if the nodes are not there, then it will be easy for you. Suppose without these nodes, these branches are not there. Let us suppose the question is like this. Okay, for finding VTH, it is very simple. For finding VTH, it is very simple. But whenever there are resistances, this is like this. So applying a nodal analysis is a bit difficult. Applying the nodal analysis is a bit difficult. So that's why we have to go for some other methods. Okay, you have to go for some other methods. That is the important point you have to identify. So always, if they are asking means from the either Thevenin's theorem or Norton's theorem or Thevenin's theorem, see, observe this. Whenever they will give either they will include the dependent sources or they will include the resistances in the bottom line of the network. So you have to be very careful. Suppose if you write the VTH, you cannot take this one as a ground. If you take this one as a ground, you cannot take this one as a ground. That is the important point. If you take this one as a ground, you can take, but you cannot take this one as a ground. So it will be one more node for you. Okay, so that's why the number of nodal equations will be increased, or number of mesh equations also will be increased. So that's why you have to search for one more method. Okay, if you observe this, see, whenever there is a resistance given means there will be one clue must be given there. Okay, definitely will give a clue to simplify the circuit. See, if you observe this is a current source in parallel with the resistance. This is a current source in parallel with the resistance, and I want to find the VTH at the load side, this terminal. So I can use a source transformation properly. Comfortable, I can write the source transformation. So if I write the source transformation, then what it will be? It is 16 into 25. 16 into 25 is 400, right? So I can convert this into one voltage source. Which kind of voltage source? It is a AC voltage source is given. Okay, one AC voltage source in series with the resistance. What is that resistance? It is 25 ohms only. Okay, so these two will be multiplied and in series with the resistance. Okay, so it is 25. So this is 400. It is 400 at an angle 0 degrees. It is plus minus, right? So it is the circuit can be drawn like this. So up to here it is completed. Okay, here there is a 15 ohm resistor. It is a 15 ohm resistor. And what it is this? What it is? It is a capacitor. So it is a capacitor minus J50 ohm, right? And there is a inductive reactance. It is of J30 ohms, and you have to find the VTH across these two terminals. Simple. You have to be careful whether he has given this one under the bottom line of the network. Okay. So it is if it is very easy now. So what we have to find? I have to find the VTH. So I can take the voltage division principle. See, it is 15 ohms. Observe this. It is one branch, right? So these all are what? It is open circuit, right? It is open circuit means these all are in series. These all are in series. There is no current in this, right? There is no current in this. So that's why these all are in series. If these all are in series means I can take this 15 ohm out and I can add this. Right or not? I can take and add this. So what is VTH? So VTH is equals to across throttle voltage into, it is 400 at an angle 0 into across the resistance divided by the total resistance. Across the resistance divided by the total resistance. What is across resistance? It is J30 ohm. J30 divided by, what is the total? 15 plus 25. It is 40 plus J50 minus J50, right? So minus J20. Okay. 40 minus J20. It is 25. 40 minus J20. So this is, so finally what you will get? Here you will get, it is, you can remove this. 110 can be cancelled here. It is 1200 J 1200 divided by 4 minus J2. Right? Right or not? So 400 into across the resistance J30 divided by the total resistance. Total resistance is 40, 25, this is 15 plus 25. It is 40 minus J50 plus J30. Okay. It is minus J20. Right? It is minus J20. Yes, correct. So this will be, and again you can simplify this. Again you can simplify this, or otherwise you can leave this as it is. Okay. So this is equivalent to, this is equals to J 1200. It is 4 plus J2 divided by, it is 4 square plus 2 square. It is 16 plus, it is 20. It is 20 now. It is 20. So 4 square plus 2 square is 20. So it is 20 into, it is how much? It is 60. Right? It is 60. So the answer will be J60 into 4 plus J2. 4 plus J2. This is the volt. Right? So this is the final answer. So this is volts. Right? You can further simplify this and you can convert into, it is what? Root over. You can write this one as root over 20 plus tan inverse of 2 by 4. Tan inverse of 1 by 2 plus 90. Okay. So you can write like this. So this will be VTH is equals to, it is 60 into root 20. 60 into root 20. It is 90 plus tan inverse of 1 by 2. So this is the final answer. This is the VTH. Right? This is the VTH. You have to identify this. Okay. Now what will be the RTH? So what will be the RTH? RTH will be, to find the RTH, I have to deactivate the independent source. To deactivate the independent source means what? I have to open circuit this. I have to open circuit this. Right? Now how it is looking like? How it is looking like? So RTH is equals to, let us suppose the current is coming like this. Okay. These two are parallel. Across these two terminals, I have to find the RTH. So minus J50, this is what? It is RTH is equals to 30. These all are series, right? These three elements are in series. Because it is open circuit, right? These three elements are in series. So this is 40 minus J50 in parallel with J30. Right? You can simplify this. So this is the RTH. Right? So like this. Welcome to Genique. So this is our next question. The question is, one network is given. So if you read that question, a DC circuit shown in the figure has a voltage source V and a current source I, okay, and several resistors, okay, it is having several resistors, okay. A particular resistor R dissipates a power of 4 watts when V is active alone, okay, acting alone. V alone is active, okay. The same resistor dissipates a power of 9 watts when I alone is active, okay. So the power dissipated by the R when the both sources are active will be. So there are options are given. So when this kind of question is coming means, so one thing you should remember. So one is active and another is deactive means one thing should come into your mind. So that is the superposition principle. Because so he is saying that what? He is saying that one source is acting alone, okay, one source is acting alone and he is giving that the response in one element, right, and another source is acting and he is giving the response in the same element something, and he asked us to find the total response when the both are acting. So it is purely related to the superposition theorem, right, it is superposition theorem. So but he is not talking about the voltage and current in this resistor, but he is talking about the power. So whenever the power is the point of discussion in the superposition theorem, you have to be careful while dealing with the powers in the superposition principle. Right? You have to be careful while dealing with the powers by using the superposition principle. So there is a limitation in this. So you cannot directly apply the superposition principle in the powers, and we will see that what it is, right. So he is talking about the power entirely, okay. So when V is acting, then the power dissipated by this R is 4 watts is given. When I is acting alone, he has given that the power dissipated by this resistance is 9 watts is given. Now he asked us to find the power dissipated by this R when both are acting at the same time. Right? Suppose if you take any network, like this, suppose if you take any network like this, suppose if you want to find the current in this, okay, suppose if you want to find the current in this element I, okay, how much the I will be, okay, how much the I will be. So first of all, if I want to use the superposition theorem, so what I have to do, first of all, I have to take one source, okay, making this one source is active and remaining sources must be deactivated, means they must be replaced by the internal impedances, okay. Suppose if this voltage source is acting, now this must be deactivated, okay. So if it is deactivated, let us suppose I am not showing that, okay, it must be what? It is deactivated, right? It is deactivated. So I am naming this one as when V1 is active. Then V1 is active. Now I am naming I1 dash, right? So I1 dash is the current, is the current across R, the current through the R, right? The current through the R, right? Now If V2 is acting, that means this is the I1 dash. Right? In this direction it will flow. Right or not? Suppose if V2 is acting alone, if V2 is active, now what happens? It must be active. So the original question was like this. It is minus, it is plus. Now it must be short circuited. It must be short circuited. Now I am naming this current as I double dash. Simply I am saying this. Okay. Suppose if this is the voltage source is acting, let us suppose this is V2. Okay. Here the voltage polarities are minus and plus. Right. It is the voltage polarities are minus and plus. Now if V2 is acting alone, okay, so what will be the current? The current I2 dash is the current through, to find the current through R, resistance R, what I am doing? First of all, I am putting one source and remaining is deactivated, right? So I am naming this one as I1 dash. Okay, so to find the response due to this voltage source V2 through R, I am deactivating this source and I am finding the current through this resistance. I am naming this one as I double dash. Now what is the total response? Then the total response will be, I dash plus or minus I double dash. This is the point you have to identify. But here what is actually, but observe this, this was plus minus, here minus plus. Definitely this I2 will be negative, right? This I2 will be negative because V2 is polarity is changed here. So I2 will be, I double dash will be in this direction. So that's why I can write this I as I1 I dash minus I double dash. So this is the total current through resistance R by using the superposition principle. Right? This is the total current by using the superposition principle. What I have taken? When V1 is the source acting alone, then I dash is the current through the resistance R and V2 is active. Now I double dash is the current through the resistance. Now the total current will be the individual currents. So this is what the superposition principle. Okay, this is the total current. When the both are acting, this is the total current. Let us suppose, observe this, when both are acting like this, okay, when both are acting like this, it is minus plus, it is V1. Let us suppose this is I dash, let us suppose this is, how the current will go? The current will go in this direction, the current will go in this direction, right? So this is I double dash. Now what is I? I is equals to I1 minus I double dash. So I dash minus I double dash. I dash minus I double dash. So this is how, this is current and this is current. Now what will be the power? The power will be the power dissipated. The power dissipated in R will be, what is the total current? The total current into I square into R. That is the point you have to identify. I square into R. How much I? I is equals to I dash minus I double dash whole square into R. This is a very important point. So this is the power, it is the total power dissipated by the resistor when both the sources are acting alone. When both the sources are acting alone. This is the total power dissipated by the resistance. Right? Suppose if I want to find the, so this is the total power dissipated by the resistor when both the sources are acting alone. Suppose if I want to find the power dissipated by the resistor if one source is acting alone. If one source is acting alone, let us suppose if V1 is acting alone, then what will be the power? The power P1 will be, how much it will be? The power P1 or P dash, P1 will be, how much it is? It is I1 dash square into R, right? Now the power P2 will be, when V2 is acting alone, what is I2? So here it will be I double dash square into R. Now what will be the total power? According to this, if I use this power, what will be the total power by using the superposition principle? By using the superposition principle, what is the power? The total power is equals to P1 plus P2. Right? P1 plus P2. How much it is? It is I1 dash square plus I dash square plus I double dash square into R. I dash square into R plus I double dash square into R. Right? So this is the total power. Right? Right? See, these are when these two individual sources are acting alone. But actually these are the two sources acting at the same time. Right? When these two sources are acting at the same time, so how much we got the exact power? The total power. It is equal to what? It is P is equals to I dash square into R plus I double dash square into R plus 2 I dash plus I double dash into R. So this is the point you have to identify. So these two are equal. These two are equal. No, these two are not at all equal. So that's why I cannot take this one as a power. I cannot take this one as the total power. So there is one more extra term is there. It is what? It is minus. It is minus here. Okay. So I1 dash square plus I double dash square I dash square plus I double dash square minus 2 I1 I double dash into R. So this is the total power. But when I have taken the individual sources are acting alone, the power is this one and this one. When it is acting, the power is this one. If I add these two, I am getting this much. But if these two sources are acting at the same time, then how much I got the power? The power I got here is this one. So there is a mismatch between these two. So which one I have to do? I have to take the actual power only. So I should not use this one. So that's why I cannot add the individual powers. I cannot add the individual powers. Right? So that's why I should go for this. So that's why you have to write a note. The note is the superposition theorem is not applicable for powers. Okay, the superposition theorem is not applicable for powers. So that is the important point you have to identify. Okay, so suppose in the given circuit, suppose if these two are positive polarities, it is positive like this. So one is coming like this and one is coming like this. So it will be also positive. Both are in the same direction. Now how can I take? This will be I is equals to I dash plus I double dash. So this is the total current, because if it is acting alone, the current direction is this one. If this is acting alone, the current direction is this one. Both are in the same direction, so the current will be added. In the previously, the currents are subtracted. Now what will be the power? The power will be plus now. Okay, here the power will be I1 dash plus I double dash whole square into R. Okay, here I will get the power. So you may get plus or minus here. In the powers, I may get the plus or minus here. Right? It is dependent on what? It is dependent on the current directions. Suppose if this total power can be written as this P is equals to I1 I dash plus I double dash into square into R. So this is the total power. So I can take plus or minus here. So plus will be for this kind of notation and minus will be for previous kind of notation. Okay, for the question. If the currents are in the same direction, I have to take the plus. If the currents are in the opposite direction, I have to take the minus here. Right? See, I am expanding this. The total power as it is I dash square into R plus I double dash square into R plus or minus 2 I1 I double dash into R. I dash, I double dash into R. If you observe this is equals to, it is P1, right? It is, I am writing this one as P2, okay, plus or minus, it is 2 root of P1, P2. Okay, if you take this I1 dash square into I2 dash square, then I will get, how much I will get? It will be I1 dash. If I take P1, P2 under root, how much I will get? I will get 2 I dash, I double dash into R, right? I am adjusting this one like this. So now, so how it can be written now? So it can be written as P is equals to P plus or minus P1 plus or minus P2 root P1. I am writing this one as root P1 plus or minus root P2 whole square. Can I write like this? Yes, it is root P1 square means P1, root P2 square means P2 plus or minus 2AB, right? 2 root P1 P2, right? So I can take root P1 plus or minus root P2 whole square. Okay, so this is the power. So this is the power. So this is the power when both the sources are acting at the same time. Okay, so this much you have to go for. Understand? So here the plus will be for the current is in the same direction, both the currents are in the same direction. Minus will be if the currents are in the opposite direction. Okay, if the currents are in the opposite direction. So this is P is equals to root P1 plus root P2 whole square, root P2 whole square. This is called as the maximum power. It is called as the maximum power. Okay, and P is equals to root P1 plus root P2 minus root P2 whole square. It is called as the minimum power. It is called as the minimum power. Right? You have to observe this. So if the two currents are in the same direction, you will get the maximum power. If the two currents are in the opposite direction, you will get the minimum power. So this kind of analysis must be done. Now come to this question. If you know this question, if you know this kind of analysis, and this question will be very easy, right? So if you come to this, what he is saying, see, when one source is, when 4 volts, see, when V is acting alone, okay, when V is acting alone, what is the power? The power dissipated by this one is how much? It is given, P1 is given. When voltage source is acting, P1 is given, how much? It is 4 watts. Okay, when I is acting alone, now the power dissipated by the resistor is R2. P2 is equals to 9 watts. Now what will be the total power when both are acting? Then the total power is equals to what? Total power is equals to root P1 plus or minus root P2 whole square. Root P2 whole square. So this will be is equals to root P1 means what? Root 4. Root 4 plus or minus root 9 whole square. So this will be, it is 2 plus or minus 3 whole square. So how will you get? Here you will get, it is 25 watts and you will get 1 watt. Okay, these both are correct. If you take minus, you will get the maximum power as 25, a minimum power as 1. So sometimes you may ask, what will be the maximum power? What will be the minimum power? So these two can be the answers for this, because I cannot decide. See, when this current is acting alone, the current is going like this. When this voltage, this source is acting alone, the current go like this. Okay? When this current is acting alone, this current go like this or go like this. I cannot decide. When it is going in this way, both are in the same direction, I will get a 25 watts. Okay. If the current is going in this direction, opposite direction to the previous one, okay, then I will get the 1 watt. So I am not able to decide the current, but for this 1 watt or 25 watts, both are the correct options. Okay, it is asked in the previous gate exam, previous gate. Okay, so both are correct answers. Suppose if we ask you to find the maximum power, you have to take the positive value. If you ask you to find the minimum power, you have to take the minus value. If you ask you to find the maximum value, you have to take the plus value. Okay, if you ask you to find the minimum value, you have to take the minus value. Okay, so this is the thing. This is the maximum power and minimum power for the superposition by using superposition theorem, right? The power cannot be applicable for superposition theorem. Okay.